Show that the function f from R to R, given by f at x equals sine of 1 over x if x is not 0, and 0 if x equals 0. Show that this function is not continuous at 0. So to do this, let's first recall what it means for a function to be continuous at a point. We say that a function f is continuous at a point x0 if, for every epsilon bigger than 0, there exists some delta bigger than 0, such that if the distance between x and x0 is less than delta, means that the distance between f of x and f of x0 is less than epsilon. So this means to show that a function is not continuous at a point, we have to find an epsilon for which there is no delta that satisfies this. In this question, the point x0 is 0, and I'm going to claim that for the value of epsilon equal to 1/2, no delta exists which satisfies this condition, and therefore f is not continuous at 0. So take any delta bigger than 0. If the distance between x and x0 is less than delta, this means that since x0 is 0, the absolute value of x is less than delta, which means that x is in the range minus delta to delta. Now, f of x minus f of x0 is f of x minus 0, which is just the absolute value of f of x. So the question that we're asking is, when x is in this range, is the absolute value of f of x less than epsilon? Question mark. Where epsilon in this case is just 1/2. To answer this question, let's look at what happens when x is in an even smaller interval, namely the open interval 0 delta. Then 1 over x is going to take all values in the open interval from 1 over delta to infinity. Now let's think about what happens to sine of 1 on x in this range. The sine function looks like this, where 0 is here, and let's say, for example, 1 over delta is somewhere here. But we can see that in this orange shaded part, the sine function goes from -1 to 1. It takes all values between -1 and 1. So this means that there exists an x in this interval 0 delta, where the value of f of x, or the absolute value of it, which equals the absolute value of sine of 1 over x, is equal to 1. And of course 1 is not less than 1/2. So therefore we've shown that for the choice of epsilon equals 1/2, we can pick any delta. This condition is never going to be satisfied by the function f. So in other words, for this choice of epsilon, no suitable delta exists. And therefore, f is not continuous at the point 0.